Good evening, fellow scholars. My name is Faith Bratton, and I'm going to be talking about our Lesson 3, Chapter 10, Length, Area, and Volume. Okay, let's get started. For question 1, we have 8 mouthfuls. And I know those look a little funny, but they're 8. Okay, and if we have 8 mouthfuls, that equals 1 Jill. Yeah, Jill. Good Jill. Okay, next we have 16 mouthfuls. I know they're not all the same size, but work with me. So we have 16 mouthfuls. 16 mouthfuls, you know how much that equals? 1 cup. But it can't just be any cup. It's got to be a Starbucks cup. Okay, because we're in college. Duh. Okay, so 32 mouthfuls equals what? 1 pint of milk. Next, we are given a pail that you take to the beach. And since we're thinking spring break, why not make it a blue pail that we take to build sandcastles? So we're giving this pail, and we're giving a gallon, a quart, a bottle, a cup, a pint, a Jill, a Jack, a jigger, and a mouthful. And we have to fill these inside our cup and see how much is left over, if we have any room left. So first, we're going to start by adding our gallon. Here we go. And the gallon takes up mostly half of it. It's like a gallon of milk. Next, we're going to pour in our bottle of water because we got to stay healthy. So the bottle will take up about half of it. Next, we have our quart, which is about like a quart of milk, I guess. Next is a pint of milk, if you're really trying to be healthy. And next would be a cup like this, the Starbucks cup. Next would be Jill, which we just saw earlier. A Jack, it's like a smaller kid. A jigger, which is like you can mix up stuff. A mouthful. But wait, we have 1 extra room right here. I'll show you right here. Let me get a little bar. Okay. Right here. See this spot that I'm circling? It's extra room. So that means we can have another mouthful. So 2 mouthfuls. So now it is full. But before we were not completely full, so we were able to add another mouthful. Okay, let's erase this because obviously it's... Okay, here we go. So for question 2, we will be finding the perimeter and the area of this triangle. First, we know that a triangle has a base and an altitude h, and they have a given area from the formula a 1/2 BH. The area of this triangle, let's see. Hold on a second. Okay, so this is the formula we will use. A equals 1/2 BH. Okay, use the base of this triangle, which is 82.3 meters, and the altitude, which is 41.0, which is in the middle of the triangle. Okay, so we use that because the base and the altitude are both in meters. We will use the term m. The units of the area will be square meters or m squared. Okay, so we will substitute the values of what we were just told, the b and the h, the base and the height, and we'll plug that into this formula. Okay, so we'll put 1/2, using the formula right here, 82.3 meters times 41.m, and we equal this. So this is our area. But next, since we found the area of this triangle, we are also asked to find the perimeter of the triangle. So by adding all the lengths together, we will find the length of the sides. So we'll do, the perimeter is just all the sides added together. So 82.3, 48.0, 69.0, and we turn out to be 199.3 meters. Okay, next for question 2, we're given this triangle, and it wants us to find the perimeter and area of this triangle. So of course, we're going to use the same formula we just did, which was the 1/2 minus BH at the bottom under the triangle. And we're going to start it off. So we're using the 2 sides, 88.8 and 37.0. But this time we are using inches, so we're going to use the term IN for abbreviation. Then we know that the altitude is 37.0, so we plug them into the formula, and we get 1,642.8 inches squared. Okay, now we substitute the values in to find the perimeter. The perimeter is adding all the sides up, so we do 88.8 plus 38 inches plus 96.2 inches, and we get 223 inches. Okay, for question 3, on this final triangle, we need to find the perimeter in the area. Let the base of the triangle be the side of the length. Let the base of the triangle be the side of the length 6.2 meters. The altitude is 2.6 because the base and the altitude are in units of centimeters, so we will use the term cm. The units of this will be squared centimeters or centimeters squared, cm. Substitute the values in to find the area of the triangle. Okay, so we're going to substitute them in. The formula we just used, the A equals 1/2 BH. And we're going to put 6.2 centimeters times 2.6, and we get 8.06 inches squared. Now we have to find the perimeter like we've just been using, so we do all the sides added together. So we get 6.2 centimeters plus 3.1 centimeters plus 8.5 centimeters plus 17.8 centimeters. Therefore, the area of this triangle is 8.06 inches squared, and the perimeter is 17.8 centimeters. For question 2, we are also given, or 3, we are also given the area of the circle we must find. Okay, so we're going to use the equation pi r squared. The area of the region between the circle is the area of the larger circle minus the area. Okay, so first we're going to find the area. So we have pi r squared equals pi 5 squared equals 25 units squared. Because see, we're given a circle, and we know that the circle from the given equation was 10. So we know that half of the circle would be 5 because 10 divided by 2, or it's half. So we notice that the sides of the length is 10 of the diameter of the circle. This means that the small circle has a radius of 5. So by finding the area, we do pi r squared, and we do that, what we just did, and we get 25 units squared. Okay, the larger circle has a radius equal to half the diagonal of the square. To find the radius, use the Pythagorean theorem, which states that if a right triangle has lengths of A and B and its hypotenuse has length C, A squared plus B squared equals C squared. As C. So we plug in the radius, which we got was 5, into the A squared plus B squared equals C squared, the Pythagorean theorem. So we get 5 squared plus 5 squared equals R squared. So we get 50R squared. Okay, so now we subtract. Since we found this, we found the area of the large circle. Substitute 50 for R squared into the area formula that we used earlier. Okay, so subtract the area of the smaller circle from the area of the larger circle to find the area of the regions between the circles. The smaller circle and the region between the circles both have an area of 25 pi units squared. So this is the area. So for this, we got the area of the large circle, we plugged it in, and we got 50 pi units squared since we've already got, we plugged it into the formula. And so the area of both is 50 pi minus 25 pi, and we get 25 units squared. Okay, for question 4, we must find the volume of the circular cone, the cylinder, and the sphere. First, we need to find the volume of the cone, cylinder, and sphere. Using the formula, use the cone, which is pi radius squared times height. Okay, so we know that for this sphere, we must use this formula for the cone. Okay, to find the volume of the cylinder, we must use this. The sphere, we must use this formula. And for the volume of the cylinder, we use this formula. Okay, and so we've already went ahead and plugged them in. And to find the volume of this, this gives us the information for the ratio of the volumes of the cone to the sphere, 1, 2, and 3. To explain our ratios, we know that the expressions for the volumes have been found, as you can see, 2/3 pi r cubed, 4/3 pi r cubed, and 2 pi r cubed. They can be compared, and since the goal is to prove that the volumes of the cone, sphere, and cylinder are in the ratios of 1, 2, and 3, divide all three of the volumes by the cone, or by the volume of the cone, which is quantity that corresponds to the 1 in the ratio. If we divide the volume of the cone by the volume of the cone, the result is 1. If we divide the volume of the sphere by the volume of the cone, the result is 2. If we then divide the cylinder by the volume of the cone, the result is 3. So showing this, it shows that our ratio is 1, 2, and 3. Okay, for question 5, the figure on the left is a trapezoidal prism. To find the surface area of this prism, we know that H equals height. And the basis of area B and the perimeter P is shown with the formula. As you can see, A equals 1/2 A plus B equals H. Notice that the two bases are trapezoids. As you can see, we have like the top one, and then under it would be another trapezoid. The area B of a trapezoid with bases A and B and altitude H is given in the formula. So we plug it in. Next, we find the perimeter of this. But first, we're going to figure out what the rest of this is. Okay, so we plugged in, so we have the formula B equals 1/2 A plus BH. So we're going to plug in the information that we have, and we're going to get B equals 258 centimeters squared. For the perimeter, we know that we always have to add up all the sides. So it's 26 plus 12 plus 17 plus 15 equals 70 centimeters. But then we have to find the surface area. So we're going to use this equation, 2B plus pH equals SA, which is your surface area. So we're going to plug in the information, 2 times 258 plus 70 times 4 equals 796 centimeters squared. Okay, for question 5, this is the other diagram that they want us to work out. So we know that the bases in this figure are triangles. The area B of a triangle with base B and altitude H is given by this formula. So this is the formula we will be using. We're going to use this formula to find the surface area. So we're going to this formula to use the surface area. So first, we're going to fill in the information for our first formula to find the base. Okay, so we're going to plug in 8 and 15 because we know that's our base and our height. And we get 1/2 times 8 times 15 equals 60 meters squared. To find our to find our perimeter, we have to just add up all the sides. So it's 8 plus 17 plus 15 equals 40 meters. For our surface area, we know we have to plug in the information. So we get 2 times 60 plus 40 times 7 equals 400 m squared. For question 6, we are asked to find the surface area and the volume of this solid. Okay, this figure can be broken down into a cylinder and then on the sides 2 hemispheres, which are spheres. Then notice that the hemisphere can be added to make spheres. The equation we will use for the surface area of a sphere is S equals 4 pi r squared. Next, we find the lateral area of the cylinder, that the cylinder can be flattened out into a rectangle, where the length of the rectangle is the perimeter of a cylinder and the width of a height. The equation for the lateral area of the cylinder is S equals 2 pi RH. So we're going to add these two equations together to figure it out. So where R is the radius and H is the length of the cylinder. So we're going to plug all our information in, and we're going to do 2 pi times 4 feet times 21 feet plus 4 pi times 4 feet squared. And we're going to get the surface area is 729 feet squared. Okay, now we need to find the volume. To To find the volume, we're going to use this equation, 4/3 pi r cubed plus pi r squared h. Plug in our information, 4/3 times pi times 4 feet cubed plus pi times 4 feet squared times 21, and we're going to get 1,324 feet cubed. For this equation, we're going to do the same thing. They've given us our information, and we're trying to find the surface area. Okay, so we're going to use this equation like we just used previously. And we're going to plug in our information. We got SA, and then your surface area times pi times 2m squared plus pi times 2 times 6 plus 2 pi times 2 times 10. And we're going to get 176 meters cubed as our surface area. But they also want us to find the volume, so we're going to use the same formula we just did, but this one, because it is it's in the shape of a rectangle if it's flattened out. Okay, so we're going to plug in our information, but we have to notice that, wait, we don't have our height. So we have to go back to what we previously talked about and use our Pythagorean theorem to find our height to plug into our information. Okay, so we're going to use the Pythagorean theorem, which is 8 squared equals 6 squared minus 2 squared. And you're going to take the square root of that, and you get 5.6 meters. So then you can plug it into our big equation, and as you can see, and you get your volume equals pi times 2mr plus times m, or 10m plus 1/3 times pi times 2m squared times 5.66 meters, which was just our height that we just found, and you get 149 meters cubed. Okay, so that's all I have today. I hope you have enjoyed your my presentation. You have learned something from this. So I hope everyone has a great spring break and stay safe. Thank you.